Hi everyone, I hope you're all okay and settled. I would like to welcome you to the sixth webinar. This week we'll be talking about the inner workings of the JavaScript language. We'll be taking a deeper look into the language, its engine, how it works internally. Um, it's awesome to work with JavaScript, as I'm sure you've already noticed, but to work with it more effectively and take advantage of all of its features, we should know more about it, about how it works, and know more about the language itself, and not just write code simply and do and watch what happens. The emphasis today will be on a specific part of the JavaScript ecosystem, and that's the event loop. Before we get into that, I would like to congratulate all of you that managed to complete the memory game project. You should be very proud of yourselves for the hard work you put in over the past few weeks. You've made the second step towards graduating from the nano degree, um, and this step was really challenging. I know that because I have been through it as well, and I know how difficult the memory game project is. And props to you for going through it, going through all of its challenges, and managing to do it in the end. I'm sure that you've learned a lot during this project, and you feel better equipped to tackle all the other projects as well. Um, Enough of the introduction. Let's begin with the presentation I have made as always. I will be sending this to you along with a file for the resources. Um, Hopefully at the end we'll get a chance to look at some of the mini projects that I posted in the session group on Slack. Hopefully, I'll get to have time to explain a bit more in depth what's actually going on, because those of you that haven't yet completed the project, maybe will find that beneficial, and of course, the ones that have already completed it can see a different view or a different way to construct the project. But we'll do that only if we have time, because this topic is a bit more complex and it will take a bit more time. Okay, let's get going. Um, Screen. There it is. And here is our topic. Um, the event loop. Right, so this is the agenda. We'll take a look at how JavaScript works. Then we'll take a look at the call stack, what blocking means, and finally, we'll take a look at the concurrency and the event loop. Um, there may be only three topics here, but trust me, these three topics are worth explaining, and I probably won't be able to explain them um, the way I want, because we have limited time, and these projects are these topics are huge and very important. So um, we should always refer to them and know what they mean. Okay, so this is a question I'm sure some of you have asked themselves. How does JavaScript, what is JavaScript actually? Okay, I have several years of experience working with JavaScript, and a while back I thought to myself, well, how does JavaScript actually work? Which is strange, because I had been using it on projects, and and I've got them working. So how can I not know how JavaScript works when I've used it and I've constructed projects with it? But weirdly enough, I did not know how JavaScript worked. I just wrote code and looked at the screen, which showed what I wanted. Well, some of the time actually. Um, so I thought it was weird using something that I didn't know how it works. I mean, I had heard of V8, Google Chrome's engine that runs JavaScript, HTML, CSS, and all that. Though I didn't really know what that meant and how it works, actually. I'd heard things like single-threaded, obviously I'm using callbacks, all that kind of stuff. But how do callbacks work? I started a journey of reading and research and experimenting in the browser, which basically um, started by me wondering what JavaScript actually is. So let's actually see what it is. And here on the screen, you can see a definition. So JavaScript is like a single-threaded, non-blocking, asynchronous, concurrent language. Okay. um, what? Single-threaded, asynchronous? What does this mean? Okay. JavaScript has a call stack, an event loop, a callback queue, and some other APIs and stuff. Hmm. So I'm not really sure what that means. I don't have a computer science degree. These are just words I don't understand. So I had heard about V8 and the various runtimes, in different browsers. So I looked to V8 to understand if it has a call stack, an event loop, a callback queue, and some other APIs and stuff like JavaScript has. Well, the V8 browser engine has a call stack and a heap. Uh, okay. I don't know what either of those are. Um, so the situation was becoming rather difficult for me when I realized that I don't really know anything about how JavaScript works. And I neither knew anything about what Chrome's engine, the thing that I use to display what I'm writing in code. I didn't know either of those things. Um, I just knew how to write code that I think I know what it does most of the time. Um, there were times that when I was writing code to accomplish something, I didn't really get to do um, what I wanted, not because the code I was writing was wrong, but I simply lacked the knowledge of how JavaScript works under the hood. So if you know how JavaScript works under the hood, you can always tell um, why your code is working or why it is not. And without that knowledge, you're just guessing if what you're gonna write is going to do what you want to do in the browser or anywhere else. So I thought that it was finally time to dive into the inner workings of JavaScript and understand how it works. So when I write code, I at least get a notion of what is happening and why it's working the way it is. So we're not talking about, you know, knowing all the JavaScript language source code or the Chrome V8 source codes. Um, that's uh, that's the job of more technically oriented people. For front-end web developers, you just have to know the basics to get the right code, and once you get better at code, then you should dive in more deep to know how to use various features of the JavaScript language. Um, Also, you should know that the way JavaScript works is one of the very attractive topics for interviewers to ask when you're applying for a job. This is because not all developers know how JavaScript works. So it's very common to encounter questions about the inner workings of JavaScript when you're on a job interview. And funny enough, this happened to me when I was interviewing for a mentor, actually. So it's very common, and you should know at least the basics if you're applying for a job. Um, so this is what I want to share with you today. Hopefully, this will be useful if you're relatively new to JavaScript, and will help you understand why JavaScript is so weird at times when you compare it to other languages you might have used. Why callbacks are such a big thing, um, and that cause us big pains at times, and but why they are required. And if you're an experienced JavaScript developer, hopefully I'll give you some fresh insights into how the runtime you're using works so you can think about it a bit better. Okay, so let's have a look at what JavaScript runtime is. Now, I don't know if you can see it all that well, the image here. Runtime is the environment in which JavaScript code is executed. Examples of runtimes are your local computer environment, servers, the browser, Node.js, all that stuff are environments that you can write JavaScript code in. And what you should know that is that JavaScript behaves differently on different runtimes, and that's why we kind of get this separation between backend and front end developers. Backend developers don't usually write code in the browser. They write it on Node.js or locally, and usually they have to um, comply with a whole different set of rules in order to get their code running to the front-end developers who just write code for the browser and not in locally or in Node.js usually. Um, Here we have a picture, as you can see here. This is a simplified view, really, of what a JavaScript runtime is. Um, on the left, you can see here the heap is where memory allocation happens. We don't really need to worry about this right now. It's a bit complex to learn and is not really the job of the front-end developers to know, really. So if you're interested in learning about the heap, you can check out, there's many articles online. What we'll focus on is right this here, the stack. Um, Here is where your stack frames are and all that kind of stuff. Here you can see functions being called and execution contexts. That's something we'll learn about next week. It's about the scope of where code is run, but right now we'll focus on the stack. Um, so if we actually clone the V8 code base, so the V8 engine is essentially the runtime or the environment, as you can um, use them interchangeably. You know, runtime, environment, they're the same thing. It's where JavaScript code is executed. Um, if we clone the V8 runtime, um, we and look for things like set timeout, the function set timeout, or the DOM or HTTP requests. Well, we'll find out that they're not there. They don't exist in V8, which was a surprise when I first found out. So how come set timeout, the DOM, and HTTP requests are not parts of the V8? So where do we get them from if they're not in the V8? Well, set timeout is one of the things that you normally do when you first start out with JavaScript's asynchronous features. So it's weird that it's not in the V8 source code in which the JavaScript code is executed. Um, okay, so this is really the bigger picture. Notice how in the previous slide we have just this small part, the JavaScript runtime in the browser, the V8 engine, and here we have two or even three extra features, the web APIs, the event loop, which we'll study, and the callback queue. So really, this is the bigger picture. This is what I'm hoping to get you on board with today and understand what all these little pieces are, how they fit in, and how they work. Just to get you acquainted with them, and hopefully you'll get on later to understanding them a bit better because they're really key for your skills as a front-end developer. Um, so we have the V8 runtime here. We studied that in the last slide. But when we have these things called web APIs, which are extra things that the browser provides us, here as you can see the DOM is located in the web APIs, AJAX, the HTTP requests, and set timeout. In the last slide, we said that they're not in the V8, and here we find out that they are indeed in the web APIs. Okay, then we have this mythical event loop um, and the callback queue. I'm sure you've heard of some of these terms before, but maybe you don't quite understand how these pieces pull together. Um, we'll find out about it in the course of this webinar. Let's first see what the call stack is. So JavaScript is a single-threaded programming language, single-threaded runtime. It has a single call stack. Okay, and it can do one thing at a time, which is what a single-threaded means. So the program can run one piece of code at a time. This is essentially what single-threaded means. So when someone says to you, JavaScript is single-threaded, what they actually mean is that your JavaScript code is run line by line and waits for every function, every expression to evaluate and to return before moving on to the next piece of code to be executed. And that's really typical of JavaScript. The other languages have multiple threads, like Ruby. There you can execute separate pieces of code simultaneously. Well, here in JavaScript, that's not an option. You just have one piece of code um, uh, running at a given time, and there's well, no way to execute two pieces of code, so you can't have two functions running at the same time. This is very important to know. So let's try and visualize um, to get our heads around this. So if you have some code like this here, um, we've got a few functions. Function multiplier here, which multiplies two numbers, square, which takes in a number and returns the multiplication by using the multiply function with the numbers we've specified, and the function print square, which takes in a number. It assigns it to the squared variable gets created, and it's assigned to whatever the square function returns, and then it console logs the return results. And here we just call the function which triggers this sequence of function calls. So hopefully this code makes sense. This is something you'll see in a lot of interview questions as well. So it's good to know um, how to get your head around this. Um, the call stack actually here. This is what the call what we're gonna use to represent the call stack. It's basically a data structure which records where in the program we are. So if we step into a function, like for example, we call print square, uh, uh, we put the function on the stack, um, and if we return from a function, so when here we return from a function, we pop the function off the stack. So firstly, by calling here, um, actually that's all the stack can do. So if you run this file, there's a kind of a main function here, print square. So it gets put onto the stack. Um, then it stays on the stack. Squared is created, the variable squared, which calls the square function here, and the square function moves onto the stack as well above the print square. Print square stays there. The square function returns a call to the multiply function. That calls this multiply function here, which gets on the stack. So now we have three functions in the call stack. And once we call this multiply function with 4 here, so notice that the 4 gets passed first on print square, then on square, and the multiply function calls 4 is called with 4 as the A argument and 4 as the B argument, so it returns 4 by 4, which is 16. So now this function multiply returns, and we can remove it from the call stack. So now on the stack there are only square and print square. So when multiply returns, we get into this return statement, which here is the result of this return statement, which is 16. And once this square function returns, we remove it from the stack as well. And we get into the print square function. This squared variable here is now equal to 16, as that's what is returned from the previous functions. And we simply console log that to the console. So here we're gonna console log 16, and once we do that, this function returns. I mean, we've not written return, but it's implicit, and this function finishes its job, so we can remove it from the stack, and that's all the stack does. So that's like a visualization of the call stack. Um, Hopefully it makes a bit more sense. Um, Definitely have a look at this and attempt it for yourself to just get your head around it, because you're likely to encounter something similar in tests or job interviews, hopefully. um, And now let's see what blocking the stack is. This is like a jargon that developers use when something goes wrong. Um, so when the call stack cannot finish or a function is getting called many times over and over again. That's what blowing the stack means. Um, Here you have some functions that call each other. Firstly, we have the foo function, which throws a new instance of the error object, which calls oops. We have the function bar, which calls the function foo here defined, and finally we have the function baz, which calls the bar function here. And immediately after declaring these functions, we call the function baz. So notice here we get, this is the result actually of calling this code. Um, but when we call baz, it gets put on to the call stack. So here we have a representation of the stack frames. So this is the state of the call stack when the error occurs. So firstly, we put the baz function here, first and foremost. Notice here we have an anonymous function. This is the main function that runs all the time, that calls your code. So um, firstly, we have the baz function called, then baz calls the bar function, and that bar function gets put on top of baz, which calls the foo function, and now this function is running, and it gets put onto the call stack, and in this function, the foo function, we throw a new error. So that error is printed here, which shows us the state of the stack when the error occurs. So now we have three functions here. If this was just a normal function that didn't throw an error, first off, the foo will get off the stack, the bar will get off the stack, and finally the baz function will get off the stack. But as we're throwing a new error here, this is the state of the stack when the error occurs. Um, this is actually here called stack trace. You can see the state of the call stack when the error occurs. This is what's called blocking the stack, and I'm sure you've probably experienced this nasty thing here. So when you are working with different data types like arrays, objects, or variables, or numbers, strings, anything, you can accidentally try to submit a string, for example, where your code is expecting a number, and that's immediately gonna throw a type error, and you'll see something like this. So the next time that's called, here you can see the function in which the error is has occurred. Now let's see another type of error that we can make in, and that's called blowing the stack. This is a function here, the foo function, that calls itself over and over again until it eventually sits in the stack about 16,000 times. And that's when the call stack kills the execution of the code and throws an error. So notice how we've declared the function foo here, and it returns foo again. So we call foo, and it returns foo, which returns foo, which returns foo, and so we get here the same function put on again and again in the stack until it eventually recognizes that something's really wrong here, and it stops the execution of the code and makes you find out the error. until you actually fix the code and run things again, hopefully fixing that error. The same thing happens with loops, so if we're not careful. So if we're looping over um, some numbers or items, or when we're using specifically the while loop, if we're not extremely careful, we can actually do something like this. If we've specified an array from say from 1 to 5, and if we're looping over that array with a while loop, and if we say that if number is not bigger than 6, don't stop the loop. And since we have numbers that are all less than 6, that loop will run forever and the browser will eventually break. So we have to be careful with loops, because the browser won't throw a type error or any kind of error. It will just break and we'll have to restart it over, and that's a really nasty thing. So be careful with loops when you're working with them, because you might blow the stack. And now that you know what blowing and blocking the stack means, I'm sure you will try and avoid that. Uh, so the big question uh, then comes is like what happens when things are slow? So when their code is slow. So we talk about blocking and blowing behavior sometimes, but there's no strict definition of what blocking is and what is not blocking. So what it really is just code that's slow. So for example, console.log, the function isn't slow, but doing a while loop from 1 to like 10 billion is slow. Network requests are slow, image processing is slow, and I don't know, network requests are slow. So things which are slow um, and on the stack are what blocking means. So if we have a function that's um, trying to process like 50 images, and if we call that function, it goes on the stack and it blocks the stack because all the other code has to wait before that function finishes to run. So what happens is that we have to wait for these blocking pieces of code until they're completed in order to execute the other bits of code we have left. This is because, like we said, JavaScript is a single-threaded language. Um, the code we write runs one function at a time, and we have to wait until each and every function is finished in order to start the next one. That's not so in other programming languages like Ruby, which is their main benefit, but sometimes it can be detrimental to have um, a lot of threads, because it's hard to keep track. So that's when JavaScript's single threaded feature is um, is like a benefit. So it's more easier to track where your code is, why it's behaving the way it's behaving. Um, so it's a benefit and a downside in an equal amount of circumstances. Um, the solution to this single-threaded behavior is, or actually are, asynchronous callback functions. Um, this is something you'll learn a bit later in the course. Here we'll just have a quick example. So notice here that we again have three functions. If we if you take a bit closer look, you'll actually see that they are four. So we have a console log here, we have a set timeout function that's called here, and in it we pass another anonymous function that calls the console log. So indeed there are five functions here. Um, First off, um, the code, once we run this um, code snippet, we'll firstly console log hi. And here we enter this set timeout function, which we've set a delay of 5 seconds. So this function runs and waits 5 seconds. In the meantime though, we skip over to this console log here and we log jsconf eu. So we have hi jsconf eu, and once this 5 second here time 5 second time passes, we console log there. So we have hi jsconf eu, and once this timer finishes, we have there. So that's like asynchronous. Um, Set timeout is an asynchronous function, and in it we pass a callback. So notice how we have a call here, the function. We call this function, but back. So that's because we have a 5 second timer running, and we have to call back this function once the timer finishes. So that's what a callback function is. It's just a function that's passed into another function as an argument. That's all a callback is. And that in the stack is represented, we'll see how in a bit. So finally we get to the essence of what I wanted to talk about today. The event loop and concurrency. So concurrency, just as definition, for those that don't really know what that means from English, it's the simultaneous happening of something. So in programming terms, it relates to threads. Remember that JavaScript is a single thread language, so here we get another thread and threads actually. Like we said earlier, um, we can only execute one line of code at a time in JavaScript. Essentially, we can do, we can't do actually two things at once. In the browser's V8 runtime, however, it turns out that we can. And that is so only because we make use of the event loop. And so let's see how that happens. So JavaScript, the runtime, can only do one thing at a time. Now that we've got that down, we know that it can't make an AJAX request while you're doing other code. It can't do a set timeout again while you're doing another piece of code. The reason we can do things concurrently or like simultaneously is that the browser is more than just the runtime. And notice that we have this picture from a few slides back. So now we'll try to make a bit more sense of it. The JavaScript runtime can do one thing at a time, but the browser gives us these other things here, the web APIs, the event loop, and the callback queue. The web APIs are effectively threads. So we have the single thread of JavaScript, and here we have the APIs, which give us other threads. And those pieces of the browser are what are aware of this concurrency when you make a call to their pieces. So if we try the AJAX request, The web APIs know this and kick another thread off besides the main one that we have. So they're essentially giving you extra threads to run your code in and make the programming multi-threaded. If you're a backend person, this diagram looks the same for Node.js, but instead of the APIs, we have C++ APIs, and the threading is being hidden from you there. So now that we have this picture, let's see how this code runs in a fuller picture of what a browser looks like. You see, I've stopped it in the execution process just to get a better glimpse of the more important parts. So in the beginning, you have to have a bit of imagination here. Um, in the beginning, image that there shouldn't be nothing on the stack here, or the console, or the web APIs, or the task queue. Let's just go back here. So we have the same code that we had a bit earlier. First off, what happens is that the first console log here, the console log of hi, is put on the stack there, and it executes. Right here, this is the result we have in this picture of this. And once the log is completed here, it's removed from the stack. And here is like where we catch up with the image. Set timeout is put here with the CB function, which stands for callback, that's logging after 5 seconds. So what would normally happen in the JavaScript runtime if we were not in the browser uh, would be that this set timeout function will sit here for 5 whole seconds, and the code here will not move to the next console log. And after 5 seconds have passed, we'll get the log here, there, and we'll have hi there in the console. And after that, we will log jsconf EU. So that's what will happen if we were not in the browser. So if we were in a single threaded runtime, which is the JavaScript runtime. But now that we have the web APIs, if we return here, this set timeout function will get popped off the stack, but the callback function will be transferred to the web APIs here, and the timer of 5 seconds will sit here and wait to finish, and we will immediately move on to the logging of JSConf EU. So essentially, the web APIs allow us to proceed with the code's execution and put the next console log on the stack, print the message, and remove it from there. Um, After the timer finishes, so now here we have the log, the JSConf view, and after the timer finishes, the callback function is put in the task queue. We'll see that a bit in a second, and not in the call stack. So here the CB, the callback function, goes here in the task queue. It's not put on the stack for execution because that will be really random behavior. This is very important to know. It gets put in the task queue, not in the stack. Um, the callback function is put on the task queue. This is where finally the event loop here comes in. So the event loop's job is to look at the stack and look at the task queue. If the stack is empty, it takes the first thing on the task queue and pushes it onto the stack, which will effectively run it. So notice here that now the stack is empty. We have logged hi and JSConf EU, And the web API's thread is also empty because the timer has now finished, 5 seconds have elapsed, and we have the callback function which is logging there, the string there. It's already put on the task queue, and right now, as you learned just a minute ago, the event loop's job, and its only job in fact, is to monitor the task queue all the time. Just look at this and look at the stack. And the very important thing to know is that if the stack is empty, the event loop will look at the task queue, and if there is any code there for execution, it will put the code that needs to be executed from the task queue onto the stack. So essentially, this is what happens. Notice how in one slide it's in the task queue and now it's in the event loop because the stack is empty. The stack is empty. If there were some other functions here stacked on top of the other, the callback function will not run. So um, if we have like a loop here running in the code that loops from 1 to, I don't know, 1,000, firstly, the loop will have to finish. It will do all the computations up until 1,000 before the callback function in the task queue is put for execution. So we will not log there until all the synchronous code has finished. Remember, set timeout is asynchronous code. So that's essentially what the event loop does. The event loop checks if the call stack is empty and if there's anything on the task queue, and if both of these conditions are true, it pushes whatever is in the stack on whenever whatever is on the task queue, it places it on the call stack. And so that's all there is to it. The event loop's only job is to monitor the stack here and the task queue and make sure that once the stack is empty, it pushes code that's waiting in the task queue onto the stack. And with that sequence of events, we get that the output in the console is hi JSConf.eu, and once the callback finishes, we put there here finally. And that's pretty much it. Another thing I want you to note and to remember here is that this only happens in the browser. Outside of the browser, the behavior is very different. If we were to run this code outside of the browser, um, we would get we would have to wait for the set timeout to finish. So we have to wait 5 seconds. We would lock hi, then we would get to the set timeout where we have to wait 5 seconds and nothing is done other than waiting for 5 seconds. And once that time finishes, we will log there, and finally we will proceed to the final code that logs JSConf EU. So the final output will be hi, then there, and finally JSConf EU. That's the main difference. If we're running in the browser, we get to use the web APIs. Um, I definitely urge you to check out what the web APIs are. They make it possible to get resources from servers or for other web pages um, via the HTTP requests. Um, they store the DOM actually. So when we're doing manipulations with the DOM, we actually access the web APIs, and that happens in another thread. So we have multiple threads which we can use to execute our code efficiently and quickly and without any interruptions. So without blocking the stack or without blowing it. And that's why browsers are really useful to us. Actually, browsers are becoming more and more sophisticated nowadays, and the web APIs, the event loop, and the task queue are just a small part of why they're really handy for us developers. And I definitely urge you to check out what the web APIs provide you with in terms of features and resources. So all the skilled developers use the web APIs, the call stack, the event loop, and the task queue. And when you use all these things, you get many threads. And like I said, you can execute code asynchronously using the other threads, and you can do more actually than just wait for a block of code to finish. Um, and that's actually what I had to say. I prepared a bunch of resources if you want to further study the sequence of events that happen in the browser when it's executing JavaScript code. Um, Here they are. First off, of course, I have chosen the Mozilla Developer Network, or MDN, as we know that it's the best, actually, the best resource for any theoretic concepts. Like I said, if you're not very intimate with the computer science part of programming, you're probably better off just finding your own resources, like articles on Medium or the W3C standards to look for information. But I definitely recommend you always, first and foremost, check the MDN for what you're looking for because, like I said before, um, very skilled developers from all around the world contribute, and only when they reach an agreement on a topic do they publish their statement on it. So you can always count on the MDN to provide timely and correct information for what you're looking for. So that's what here the first resource is, uh, concurrency in the event loop. The next one is an article on Medium that I used to get some of the information I presented to you a few minutes back. It's called Understanding the Event Loop. Um, it's from hackernoon.com. That's another famous website that has content which is published by skilled developers that work in the um, critically acclaimed companies like Google and all the others. And finally, we have a video on the event loop on YouTube. Um, this video, I extremely, I'm extremely happy that I came across this video on YouTube because it's from a JavaScript developer, which is a professional. He's paid to do it, and he has a knack for presentation, so it makes things that are really complicated seem really simple. And Um, I definitely urge you to um, go and watch it. It's like 26 minutes, so it's not gonna take much of your time. It's part of the JavaScript conference EU, so part of the slides that I showed to you, part of the pictures are what was shown there. So um, they, the presenter really takes an in-depth analysis on the topic of the event loop, the call stack, and all the others. And I think that in the end, he produces a really um, easy to understand um, interpretation of all these really complex topics. And so I definitely suggest you take a look at it. And finally, I would like to again congratulate all of the all of you that managed to complete the projects. Sadly, we won't have time to um, take a look at the codes, the projects that I have shared with you. Um, I I want to remind you that the deadline for the second project is this Sunday. So I wish to I wish you luck in preparing the project. Um, remember that these are soft deadlines, so no penalties will happen if you don't get the project done by Sunday. So, but really, I suggest you try to get it done before the deadline because these deadlines are computed over the past. Um, this is the experience Udacity have, and they've set these deadlines. So if you choose to follow them, you're essentially guaranteed to complete the nano degree on time and graduate. So I definitely urge you to try your best. Um, Also, if you encounter problems, feel free to message me. I'm here all the time, here to explain this. I've most probably um, come across all the issues you're currently facing. Um, and as another tip, I I can tell you that if you're feeling that you're stuck on the project, you don't um, really know what to do next, I suggest just submit it for review. You can submit all the projects for review many times, and what you'll get in terms of a review will be essential for you because this is what the reviewer will want uh, for you to complete before um, actually granting you with the status that your project is finished, so it's complete. So um, the way I did it is to submit my project every now and then to get feedback from the reviewer and work on my code. So that's it for today. I guess I'll try to make another project before Sunday that shows another part of the code that you need to um, complete the project. I wish you all the luck, all the inspiration and motivation for the second project. Like I've said, I'm here to help you if you need anything. And I guess I'll see you next week. So thank you for sitting out this um, difficult, I might say, topic. And good evening, and see you next time.